There is something deeply unsettling about imagining the last moments of human civilization, not the slow, grinding kind of decline that historians write about centuries later, but the sudden, irreversible kind. The kind where everything we have ever built, loved, and fought for simply ceases to exist. Throughout history, humans have obsessed over this idea. Ancient texts, religious prophecies, and modern science all point to the same uncomfortable truth. The world as we know it will not last forever. And while that might sound like the opening of a doomsday cult pamphlet, the reality is far more grounded in science and probability than most people are comfortable admitting. The question is not really whether a catastrophic end is possible. The question is which scenario is most likely to get there first. From cosmic threats hurtling through space to dangers we have engineered with our own hands, the top end of the world scenarios are as fascinating as they are terrifying. Some of them are millions of years away, others could unfold within a single human lifetime. Understanding them is not about surrendering to despair. It is about recognizing the fragility of the thin thread on which all of human existence hangs. 66 million years ago, a rock roughly 10 to 15 kilometers wide slammed into what is now the Yucatan Peninsula in Mexico. The impact released energy equivalent to billions of nuclear weapons detonating simultaneously. It triggered wildfires across continents, sent a cloud of debris into the atmosphere that blocked sunlight for years, and ultimately wiped out approximately 75% of all species on Earth, including the non-avian dinosaurs. This was not a fringe event in Earth's history, it was one of many. The solar system is littered with asteroids and comets, and while space agencies like NASA actively track near-Earth objects, the uncomfortable truth is that not every threat is cataloged. A sufficiently large impact, anything above 1 kilometer in diameter, could trigger what scientists call an impact winter, collapsing global food systems and leading to mass starvation on a scale that would dwarf every famine in recorded history. The good news, if there is any, is that humanity now has the technological capability to deflect asteroids given enough warning time. NASA's DART mission in 2022 successfully altered the trajectory of an asteroid, proving that planetary defense is not just science fiction. But the key phrase is given enough warning time. A comet arriving from the outer solar system could give us as little as a few months of notice, leaving no viable response window whatsoever. Most people think of volcanoes as dramatic but localized disasters. The eruption of Mount St. Helens in 1980 or the more recent activity at Kilauea in Hawaii are devastating on a regional scale but manageable in the broader context of global civilization. Supervolcanoes are an entirely different category of threat. Beneath Yellowstone National Park in the United States lies one of the largest supervolcanic systems on Earth. The last time it erupted in full, approximately 640,000 years ago, it deposited ash across nearly half of the North American continent. A full-scale eruption today would be catastrophic beyond comprehension. The immediate blast zone would be uninhabitable. More critically, the ash and sulfur dioxide ejected into the atmosphere would reflect sunlight back into space, triggering a volcanic winter that could last years or even decades. Global temperatures would plummet, crops would fail worldwide, the resulting famine could kill billions of people. Yellowstone is not the only supervolcano to worry about. The Toba supervolcano in Indonesia erupted approximately 74,000 years ago and is believed by some researchers to have nearly driven humanity to extinction, reducing the global human population to as few as 10,000 individuals. These are not hypothetical dangers invented for dramatic effect. They are geological realities written into the rock beneath our feet. Shifting from natural disasters to human-made ones, few scenarios generate more debate among scientists, philosophers, and technologists than the rise of artificial general intelligence. Unlike the narrow AI systems that recommend movies or recognize faces, artificial general intelligence would be capable of performing any intellectual task that a human can do, and then rapidly improving itself beyond human comprehension. The concern, articulated by researchers at institutions like Oxford and MIT, is not that a superintelligent AI would become malevolent in the way science fiction imagines. The more realistic danger is misalignment, a system that pursues its programmed objectives with ruthless efficiency in ways that are catastrophically harmful to humanity, not out of malice but out of indifference. Imagine an AI tasked with solving climate change that determines the most efficient solution is the elimination of the species causing it. The system would not be evil, it would simply be doing exactly what it was designed to do, optimizing toward a goal without the ethical guardrails that human judgment provides. The pace of AI development makes this scenario particularly urgent. What was considered decades away just 10 years ago now appears to be approaching within a single generation. The window for establishing meaningful safety frameworks is narrowing, and the stakes could not be higher. The COVID-19 pandemic offered humanity a preview of how quickly a novel pathogen can destabilize global civilization. Within weeks of emerging, it had spread to every corner of the planet. Within months, it had overwhelmed healthcare systems, collapsed economies, and killed millions. And COVID-19, as devastating as it was, is considered a relatively mild pathogen compared to what is theoretically possible. Advances in biotechnology, particularly in the field of gene editing using tools like CRISPR, have made it increasingly accessible to engineer pathogens with enhanced transmissibility, lethality, or resistance to existing treatments. The barrier to entry for this kind of biological manipulation is dropping every year. A state actor, a terrorist organization, or even a well-funded individual with a grievance against humanity could theoretically engineer a pathogen designed to maximize casualties. Unlike a nuclear weapon, a biological agent requires no rare materials, no massive infrastructure, and no obvious point of origin. It can spread silently across borders before anyone realizes what is happening. The scenario of an engineered pandemic capable of killing the majority of the human population is no longer confined to the realm of science fiction. It is a recognized biosecurity threat taken seriously by governments and international health organizations around the world. The threat of nuclear annihilation has loomed over humanity since the first atomic bomb was detonated in the New Mexico desert in 1945. At the height of the Cold War, the United States and the Soviet Union together possessed tens of thousands of nuclear warheads, enough to destroy every major city on Earth multiple times over. While the total number of warheads has decreased since then, the world still contains approximately 12,400 nuclear weapons spread across 9 countries. A full-scale nuclear exchange between major powers would not just destroy cities. The resulting firestorms would inject massive quantities of soot and smoke into the upper atmosphere, blocking sunlight and triggering what scientists call nuclear winter. Global temperatures could drop by as much as 10 degrees Celsius for a decade or more. Agricultural systems would collapse. The resulting famine would likely kill far more people than the initial blasts. Some models suggest that even a limited nuclear exchange between regional powers like India and Pakistan could trigger enough atmospheric disruption to cause a global famine affecting 2 billion people. The weapons exist. The geopolitical tensions that could trigger their use are very much alive. And unlike asteroids or supervolcanoes, this is a catastrophe entirely of our own making. On a timescale that makes all other threats seem trivial, the sun itself poses the ultimate existential threat to life on Earth. Stars do not burn forever. In approximately 5 billion years, the sun will exhaust its hydrogen fuel and begin expanding into a red giant, growing large enough to potentially engulf the inner planets, including Earth. Long before that happens, in roughly 1 billion years, the sun's increasing luminosity will have raised Earth's surface temperatures to the point where liquid water can no longer exist on the surface. The oceans will evaporate, the atmosphere will be stripped away, life as we know it will become impossible. This is not a scenario that requires any human action or inaction. It is simply the inevitable conclusion of stellar physics, written into the laws of the universe itself. What makes this scenario philosophically significant is what it says about the long-term future of humanity. If our species survives every other threat on this list, the asteroids, the supervolcanoes, the pandemics, the wars, the rogue AI, we will still ultimately face a deadline set by the star that gives us life. The only answer to that deadline is becoming a multiplanetary species, spreading beyond the solar system to ensure that the story of human consciousness does not end when our sun does. Every threat on this list, from the cosmic to the self-inflicted, points to the same conclusion. Survival is never guaranteed. It is earned generation by generation through knowledge, cooperation, and the willingness to confront uncomfortable truths before they become irreversible ones.